4.5 billion years. That's the number we usually hear for how old the Earth is.
Right, the standard geological age.
But what if that's like way off? What if the real story is thousands of years, not billions?
That's exactly the idea we're diving into today. It's a perspective that, directly challenges that standard timeline.
Okay.
And we'll be looking at arguments from, well, all sorts of fields. The Bible, fossils, geology, even astronomy.
All pointing towards a much younger Earth. Is that the idea?
That's the core argument presented in the material, yes.
Got it. And we're basing this discussion on material you, the listener, provided specifically a PDF called 21 Reasons to Believe the Earth is Young by a Dr. Jeff Miller.
That's our source material for this deep dive.
So think of this as a shortcut, really. We're unpacking the key arguments from that source to help you understand this perspective.
It's about exploring the ideas presented there.
Okay, so where does the source start? What's the first pillar of this argument?
Well, the very first argument presented is foundational. It starts with the Bible. The idea is, if you accept the Bible as the inspired word of God, then what it says about Earth's age should be taken as factual.
And how does the source get an age from the Bible? Is it explicitly stated?
Not exactly as a single number, no. It's based on calculations from the genealogies. You know, the family trees listed in Genesis chapters 5 and 11 specifically.
Right, the begats. So adding up the ages when people had children.
Pretty much. By summing those ages and durations, the source calculates a timeline. For instance, from creation, from Adam to the Great Flood, they get about 1,656 years.
Okay, 1,656 years. That's quite specific.
Yeah, based on those specific genealogies.
And does it continue after the flood?
It does. The source then traces the line from the flood to Abram or Abraham. That period's a bit more debated interpretation-wise, maybe 400, maybe up to 5,000 years. There's some variance there in how people count it.
Okay.
Then roughly 2,000 years from Abram to Christ.
Right.
And then, of course, about 2,000 years from Christ to now.
So add all those up. What's the total?
When you put it all together, according to the source's calculations, you land somewhere in the range of 6,000 to maybe 10,000 years for the total age of the Earth.
6 to 10,000. That's obviously drastically different from 4.5 billion.
Drastically. And that biblical calculation is presented as sort of the starting point for this whole perspective in the document.
All right, so after the biblical argument, where does the source take us? Paleontology and archaeology, right?
Correct. It moves into physical evidence found in the ground. One of the first things mentioned are polystrate fossils.
Polystrate, meaning many layers.
Exactly. These are fossils, often tree trunks, but sometimes other things too, that cut vertically through multiple rock layers, or strata.
Okay, I think I can picture that.
Yeah.
Like a fossilized tree standing upright through several different kinds of rock.
Precisely. The source mentions examples like tree trunks, yes, but also things like a baleen whale fossil found like that, certain plant fossils called chelamites, even a fossil catfish.
So what's the significance? Why is that presented as evidence for a young Earth?
Well, the argument is that those rock layers are supposed to represent vast amounts of time, maybe millions of years, between the bottom layer and the top layer the fossil passes through.
Right, that's the standard geological view, slow deposition.
But how could a tree trunk or a whale carcass stand there for, say, hundreds of thousands or millions of years while sediment slowly buried it without rotting away completely?
Ah, I see. It wouldn't survive that long exposed, would it?
That's the challenge posed. The existence of these fossils suggests, according to the source, that the sediments must have been deposited very rapidly, burying the organism quickly before it could decompose.
So rapid burial, rapid rock formation, not slow and gradual over millions of years.
That's the implication drawn from polystrate fossils in this context. It questions that slow, incremental process.
Interesting. What else from paleontology? The source mentions DNA in ancient bacteria.
Yes, this is another point. It refers to the discovery of DNA and even apparently viable bacteria in salt crystals dated to the Permian period.
Permian. That's supposed to be, what, 250 million years ago?
That's the conventional age, yes. A very, very long time.
You know, the issue is finding DNA that old.
It's the stability. DNA is a complex molecule. Over millions of years, chemistry dictates it should break down, degrade completely.
But they found intact DNA.
The source cites research, mentioning John Parks, suggesting yes, intact DNA was recovered. And even more striking, the claim is that the bacterium was actually revived in the lab.
Revived. after a supposed 250 million years.
That's the claim highlighted. And apparently this revived bacterium was quite similar to modern bacteria.
Which implies not much evolution over that vast time scale.
Or, from the young Earth perspective presented, perhaps the bacteria and the salt deposits they were in aren't actually 250 million years old at all. The preservation of DNA is seen as more consistent with a much younger age.
Okay, that's quite a claim. Moving on, the source uses human population statistics. How does that fit in?
It shifts the focus a bit. It contrasts the standard evolutionary timeline for humans genus Homo emerging maybe 2 or 3 million years ago with today's population.
So if humans have been around for millions of years,
then even accounting for wars, disease, famine, all the things that limit population growth, the source calculates that our population should be astronomically larger than it is. They make a calculation suggesting you couldn't even fit that many people in the known universe.
Compared to what we actually have now, which is
around 7.5 billion, according to the U.S. Census Bureau figure cited in the source.
So how does the young Earth model explain the current 7.5 billion?
It goes back to the biblical flood narrative, dated by the source to around 4,350 years ago.
Okay.
According to that account, humanity started over from just Noah's family, 8 people in total.
Right.
The source says that if you run population growth models starting with 8 people about 4,350 years ago, you actually predict a current population somewhere between 6.7 and 8.1 billion.
Which brackets the actual current population pretty well.
It aligns very closely, yes. That alignment is presented as strong support for the biblical timeline and the young Earth model.
Let's talk carbon-14 dating. That's often used to argue for older dates, isn't it? How does the source use it?
Well, it focuses on the limitations of C14. The key is its half-life, which is only about 5,730 years.
Relatively short, geologically speaking.
Very short. Because it decays relatively quickly, scientists generally agree that after maybe 60,000 or at most 100,000 years, there shouldn't be any detectable C14 left in a sample.
Okay, so if you find C14...
it means the sample can't be older than that, say, 100,000-year limit, logically.
And the source claims detectable C14 is found in things supposedly much older.
Yes, this is a major point. It cites reports of carbon-14 being found in things like dinosaur fossils, coal seams, even diamonds, all materials conventionally dated as being millions or even hundreds of millions of years old.
But they contain C14. How much?
Enough to get calculated ages, according to the source, typically falling in the range of 10,000 to 60,000 years.
And this is found across different geological layers.
Apparently, yes. Samples from Cenozoic, Mesozoic, Paleozoic strata, regardless of the supposed age of the layer, the C14 age comes back in that relatively young range.
So the argument is, these layers, the fossils, the coal, they can't be millions of years old if they still contain measurable carbon-14.
That's precisely the argument. It's presented as evidence that the entire geologic column might be much younger than conventionally thought, perhaps related to deposition during the flood.
Okay, another fossil-related point. Soft tissue in dinosaur bones. This one always sounds amazing.
It is pretty startling. We're talking about finding things like flexible, stretchy tissue, blood vessels, even what appear to be red blood cells inside dinosaur fossils.
Fossils that are dated to, what, 55, 66 million years ago? Cretaceous period?
That's the standard age.
And how could soft, delicate stuff like blood vessels possibly survive for 66 million years?
That is the crux of the argument. The source argues it's chemically and biologically implausible. Decay processes should have obliterated such fragile organic material long, long ago.
Has this been found in many different dinosaurs?
The source lists quite a few examples where researchers have reported finding soft tissue, T-Rex, hadrosaurs, mosasaurs, triceratops, and several others.
It's really hard to wrap your head around that kind of preservation over millions of years.
It is, and so the source argues this strongly suggests the fossils aren't millions of years old at all, but maybe only thousands. The preservation makes more sense, they say, in a much shorter time frame.
Okay. The source also touches on human and dinosaur coexistence, which is definitely not mainstream.
No, it's highly controversial. But the source does assert that there's evidence, physical, historical, and biblical, suggesting humans and dinosaurs lived at the same time.
And the implication is, if they coexisted, the whole timeline gets compressed.
Exactly. It would fundamentally challenge the standard evolutionary sequence and timescale.
All right, let's shift gears to geology. What about folded rocks, like in the Grand Canyon?
Yeah, the source points to places where you see thick layers of rock bent into tight folds, sometimes almost like folded cloth.
Oh.
The observation is that these massive rock layers are bent sharply, but often without significant shattering or fracturing.
Like they were bent when sauced.
That's the argument. If those rocks had already hardened over millions of years, becoming brittle like rock normally is, trying to bend them like that under tectonic pressure should cause them to break and fault extensively.
Not fold smoothly.
Right. The smooth folding suggests to the source authors that the bending must have happened relatively soon after the sediments were deposited, before they had fully lithified or turned into hard rock.
Which implies rapid deposition and rapid deformation.
Yes, challenging that slow and gradual uniformitarian assumption again.
You mentioned uniformitarianism, the idea that the present is the key to the past. The source questions this elsewhere too, right? With rapid, slow processes.
It does. It lists several examples of things usually thought to take a long time, but which have been observed or demonstrated to happen quickly under certain, often catastrophic conditions.
Like what?
Things like wood petrifying rapidly, oil forming quickly under specific heat and pressure, canyons being carved rapidly by massive floods.
Not just slowly by rivers over eons.
Exactly. Also, they mention evidence suggesting radioactive decay rates might have been much faster in the past, and even potentially rapid continental plate movement during catastrophic events.
So the argument is, you can't just assume today's slow rates applied throughout history.
Correct. If these processes can happen quickly, using their current slow rates to calculate multi-billion-year ages might be flawed.
Okay. What about the salt in the sea? How does that relate to age?
It's about input versus output. Rivers constantly dump sodium, a component of salt, into the oceans. Some gets removed, but there's a net increase over time.
Right.
The source calculates that starting from fresh water and using today's rate of sodium input, it would only take about 42 million years maximum to reach the current level of ocean salinity.
42 million. But the oceans are supposed to be billions of years old.
Around 3.8 billion is the accepted figure, so there's a huge discrepancy.
How do old Earth models explain that? Assume rates were different.
Generally, yes. They'd have to argue that input was much lower or removal much higher in the past. But the source argues that requires assuming rates were over 90 times slower on average than today, which again challenges uniformitarianism.
Similar argument for sediment on the seafloor.
Very similar logic. Rivers wash billions of tons of sediment into the oceans each year. Some gets subducted with tectonic plates, but a lot accumulates.
Okay.
Based on the current rate of deposition and the average measured thickness of sediments on the ocean floor, the source calculates a maximum accumulation time of about 19 million years.
19 million. Again, way shorter than billions.
Way shorter. It's presented as evidence that the oceans, and therefore the Earth, are much younger, or that deposition rates were vastly higher in the past, like during a global flood.
What about erosion between the rock layers? The source mentions a lack of it.
Yeah, think about those big, flat boundaries between different rock strata like you see clearly in the Grand Canyon walls. If there were truly millions of years passing between the deposition of one layer and the next, you'd expect the top surface of the lower layer to get heavily eroded, cut with channels, weathered unevenly before the next layer covered it up.
Makes sense. Like land surfaces today get eroded.
Exactly. But often, the contact surfaces between these supposedly millions of years apart layers are very flat and smooth, showing little evidence of such prolonged erosion. Suggesting, according to the source, that the layers were actually laid down much more rapidly in succession without those vast time gaps in between.
Okay. Helium in zircon crystals, that sounds technical.
It is a bit, but the concept is fairly straightforward. Zircon crystals often contain uranium, which decays radioactively into lead.
Right.
As part of that decay, helium atoms are produced inside the crystal. Now, helium is a tiny atom and leaks out of crystals relatively quickly. Its diffusion rate is known.
So over a long time, the helium should escape.
You'd expect most of it to have leaked out, especially from crystals thought to be, say, 1.5 billion years old. But studies have found surprisingly high amounts of helium still trapped inside these ancient zircons.
More helium than expected if they were really that old and leaking at known rates.
Correct. The young Earth interpretation is that this suggests the radioactive decay that produced the helium happened much more recently and perhaps much faster, so the helium simply hasn't had billions of years to leak out yet.
Implying a younger age for the rocks, or at least accelerated decay in the past.
Yes. The source also briefly mentions orphan radio halos as potentially related evidence for accelerated decay.
And finally, for geology, clastic dikes. What are those?
Imagine you have layers of rock, some harder, some softer. A clastic dike is when softer, unconsolidated material like wet sand gets squeezed upwards into cracks in an overlying, harder rock layer. The source gives an example, the Ute Pass Fault, where Cambrian sandstone, supposedly very old, appears to have been injected upwards into overlying Cretaceous rock, which is supposed to be hundreds of millions of years younger.
How could the old sand stay soft and squishy for hundreds of millions of years while younger rocks formed on top?
That's the question posed. It seems unlikely. The source suggests it's more plausible that all the layers from Cambrian up to Cretaceous were deposited rapidly, were still relatively soft and waterlogged, and then some event caused the lower sand to inject into the upper layers.
Again, pointing to rapid, large-scale deposition.
That's the interpretation offered.
Okay, let's look out into space now. Astronomy, astrophysics, the faint young sun paradox. What's that about?
Standard models of how stars work predict that stars like our sun gradually get brighter and hotter over their lifespan as they fuse hydrogen into helium in their core.
So the sun should be brighter now than it was billions of years ago?
Yes, significantly brighter. The models suggest that maybe 3 or 4 billion years ago, the sun might have been 25%, maybe even 30%, dimmer than it is today.
Okay, so what's the paradox?
The paradox is, if the sun was that much fainter, Earth should have received much less heat and likely would have been completely frozen over a snowball Earth.
But geological evidence suggests Earth had liquid water very early on, right? Which life supposedly needed to evolve.
Exactly. There's evidence for liquid water billions of years ago, but the sun, according to the models, should have been too faint to allow for that. How could early Earth be warm enough? That's the puzzle.
A conflict between solar physics and Earth's early climate evidence.
Within the standard long-age framework, yes.
What about the Earth's magnetic field? The source says it's decaying rapidly.
Yeah, we've been measuring the strength of Earth's overall magnetic field quite accurately since the 1830s.
Okay.
And those measurements show a clear trend. The field is getting weaker. It seems to be decaying exponentially, with a half-life estimated around 1,100 years or so.
Half-life of 1,100 years. That's really fast.
It is surprisingly fast. Now, if you extrapolate that decay rate backward...
Doubling its strength every 1,100 years going back.
Right. You don't have to go back very far, maybe only 20,000 or 30,000 years before the calculated field strength becomes impossibly high. We're talking levels that would generate so much heat inside the Earth, it might disrupt the core, maybe even make life impossible on the surface.
So the current decay rate suggests the field can't be incredibly old.
That's the argument. It puts a relatively recent upper limit on the age of the field, contradicting the idea of it lasting for billions of years.
Then there's the moon moving away from Earth's lunar recession.
Yes, the moon is gradually spiraling outwards, moving away from Earth by about 4 centimeters, roughly 1.5 inches per year. We can measure this very accurately with lasers bounced off reflectors left on the moon.
Okay, 4 centimeters a year. Doesn't sound like much.
It adds up over time. The problem is, the gravitational forces causing this depend heavily on the distance. When the moon was closer, the force was stronger, and it would have receded faster. If you calculate backwards, taking this into account, you find that only about 1.5 billion years ago, the moon would have been so close to the Earth that they would essentially be touching, or at least well within the Roche limit, where tidal forces would have ripped the moon apart.
1.5 billion years ago, but the moon's supposed to be 4.5 billion years old, same as Earth.
Exactly. The physics of lunar recession seems to suggest the Earth-Moon system, as we know it, cannot be 4.5 billion years old. You hit this physical limit much sooner.
Another timing problem based on current processes. What about helium in the atmosphere? We talked about helium in crystals.
Right, similar source, different location. Helium is produced by radioactive decay of uranium and thorium in the Earth's crust, and it leaks out into the atmosphere.
Okay.
Some helium, being very light, does escape Earth's gravity into space. But scientists can estimate both the rate helium is added to the atmosphere and the rate it escapes.
And there's more being added than escaping.
Yes, there's a net accumulation. So if you look at the total amount of helium currently in the atmosphere and divide by the estimated net rate of accumulation,
You get an age for how long it's been accumulating.
you get a maximum age for the atmosphere based on its helium content. The source cites calculations giving an upper limit of around 2 million years.
2 million. Again, much less than the supposed 4.5 billion year age of the atmosphere.
Far less. It's presented as another indicator that the atmosphere, and by extension the Earth, might be much younger.
Okay, shifting out to galaxies now. Spiral galaxies, what's the issue there?
You know how spiral galaxies have those beautiful arms?
Yeah.
The problem is something called differential rotation. The inner parts of the galaxy spin faster than the outer parts.
Like stirring coffee with cream, the swirl gets stretched out.
Exactly like that. Over time, this difference in speed should cause the spiral arms to wind themselves up tighter and tighter.
Until they just disappear into a smooth disk.
Pretty much. Calculations suggest this should happen relatively quickly. Cosmically speaking, within maybe a few 100 million years, the distinct spiral pattern should be gone.
But we see lots of galaxies that still have clear spiral arms.
We do. Billions of them. If galaxies are truly billions of years old, as standard cosmology suggests, why haven't all these spiral arms wound up and smeared out by now? That's the winding problem highlighted by the source.
Suggesting the galaxies themselves might not be billions of years old.
That's the inference drawn in the young universe context.
And finally, the comet contradiction. What's that?
Comets are basically dirty snowballs orbiting the sun. Every time they swing close to the sun, the heat boils off ice and dust, creating the tail.
So they lose material on every orbit.
Correct. They're constantly disintegrating. Because of this, comets, especially the short period ones that orbit relatively frequently, have a limited lifespan, maybe 10,000 years or so before they completely fall apart or evaporate.
Okay, 10,000 years.
But the solar system is supposed to be 4.6 billion years old.
So, where are all these comets still coming from? They should have all fizzled out long ago.
That's the contradiction. If the solar system is billions of years old, why do we still see thousands of short-period comets? The source argues that their continued existence is much more consistent with a young solar system, perhaps only thousands of years old.
What about things like the Oort cloud or Kuiper belt, proposed reservoirs for new comets?
The source acknowledges those ideas, but argues that there's no direct observational proof they exist or could supply comets at the needed rate, treating them as somewhat speculative attempts to solve the problem within an old universe model.
Okay, so wrapping this all up, it seems like a common thread through almost all these arguments presented in the source is challenging that idea of uniformitarianism, the slow, gradual processes over deep time.
That's definitely a central theme. The source repeatedly contrasts the predictions of slow, gradual processes over millions or billions of years with evidence that seems to suggest rapid, sometimes catastrophic events, or processes that yield much younger maximum ages.
Pointing to things like polystrate fossils, soft tissue, C14, folded rocks, helium levels, comet lifespans.
Exactly. All presented as pieces of evidence that are difficult to reconcile with the standard multi-billion-year timescale, but potentially fit better within a framework involving catastrophic events, like the global flood described in Genesis, and an overall much younger age for the Earth and perhaps the cosmos.
And again, it's really important for you, listening, to remember we've been exploring the arguments as presented in the source material, Dr. Miller's paper, which argues for this young Earth viewpoint.
It's one interpretation of the scientific and biblical data.
So maybe a final thought for you to chew on. If you were to consider these arguments seriously, how would it change the way you view Earth's history? How would it impact your understanding of the processes that shaped our world?
Yeah, it's worth reflecting on the assumptions that lie beneath our understanding of deep time. Thinking about these alternative interpretations might encourage you to dig deeper into these fascinating and often quite contentious topics on your own.